Welcome to the last day of 21 days of code. Congratulations on making it till here on our journey of lead code. So now let's get started with question 60, permutation sequence. The set 1 to n contains a total of n factorial unique permutations. By listing and labeling all of the permutations in order, we get the following sequence for n equal to 3. Given n and k, return the kth permutation sequence. So for example, if you are given n equal to 3 and k equal to 4, you have to return this permutation sequence 2, 3, 1. So given n will be between 1 to 9 and k will be between 1 to n factorial inclusive. So first of all, how are we calculating these permutations? So for that, I will be taking you back to your 12th class combination and permutation concepts. So if you are given n equal to 5, that is 5 numbers, 5 digits to be precise, 1, 2, 3, 4, 5. In how many ways could you arrange them so that you get different numbers, or how many different numbers could you get? So first of all, we used to fill this space as there are 5 digits, so we can take any one of them and fill it here. So this will be 5. After filling one of the digits here, we are left with the 4 remaining digits. So we can fill any of the 4 here. So 4. Then we are left with 3 remaining digits. So we can fill any one of the 3 here. So 3. Similarly 2. And we have got no choice. We have only got one digit, one last remaining digit. So we will fill it here. Cool. So we can write this as 5, 4, 3, 2, 1. So we can write this as 5 factorial. So that's why we have total 5 factorial permutations for n equal to 5. So I have written this something here, so I will explain it later. I have written that. First of all, we need to observe a pattern first. So observing the pattern in n equal to 3, we are given the first, second, third, fourth, fifth and sixth permutations in this order. So you can see that in first and second permutation, 1 is in the front, in third and fourth, 2 is in the front, and in fifth and sixth, 3 is in the front. So for the sake of solving this problem, we won't be using permutations or taking k from 1 to n factorial. We will instead be taking k from 0 to n factorial minus 1, like the indexing of an array where our array is of size n, but the indices are from 0 to n minus 1. So similarly, we will take k here from 0 to n factorial minus 1. Here n factorial is 6, so n factorial minus 1, that is 5. So 0 to 5, that will be our k. So when let's now observe this combination using that k, that new k that we obtained after subtracting 1 from. So for k equal to 0 and 1, we see that it's 1 here. So if we take all these 3 digits, we get n factorial, that is 3 factorial permutations. But what if we only eliminate the, take the first digit and keep it there for now, and then take permutations from the next digits? So taking these last 2 digits, how many permutations are we going to get from it? Well, 2 factorial. So in order to determine what number will be coming in the first position, what we will be do, we are on the ith position, that is the positions will be from 1 till n. So we are on ith position. For example, here we are on first position. So we will divide the k there with n minus I factorial. That is, I is the position, so n is 3 minus I, that is 1. 3 minus 1, that is 2 factorial. So k here, we are given k equal to 4. So we divide 4 by 2, or for example, let's take the k's here for example. So k are 0 and 1. When we divide 0 and 1 both by 2 factorial, so we get answer equal to 0. 0 divided by 2 is 0. 1 divided by 2 is also 0. We will take its floor value. So when we get quotient equal to 0, we will take the first index. When we get quotient equal to 1, that is in case of 2 and 3, we subtracted 1 from them. So 2 and 3, when we divide it by 2 factorial, that is 2, we get quotient equal to 1. So we will be taking element on the second or the q index, that is q is equal to 1. So we will take the element on index 1, so that is 2. Similarly, for 4 and 5 here, when we divide it by 2 factorial, we get 2. So we will be taking element on the index 2, so it's 3. So that's why there's 3 here. So now that we have observed a pattern, let's now apply this pattern here. So first of all, we have been given this set here, and this set is actually an array in which elements are stored in order. So elements are stored in order from 1 to 5. The element should be in this order. So we will define, first of all, let's take a k, a random k, like k is equal to, let's take 53. So k will be equal to 53, and let's take a variable q which will store the division of this n minus I like k by n minus I factorial, k divided by n minus I factorial, where I is our current position, that will be from 1 till 5 here. So, and one more variable r, that will store k modulo n minus I factorial, that is the remainder left. So first of all, for this position, we will divide k with 4 factorial. Why? Well, imagine if our k was between 0 and less than 24, that is 0 to 23. Then what would our quotient be? The quotient for 4 factorial, that is 24. So k is between 0 and 23 divided by 24. That would have given us 0 because floor value. So when we got 0, we know that we have to take the element on the first index. So taking the element on the first index, now we are left with the remaining 4 elements. So now we have to take one element from those remaining 4 elements, and rest 3 elements we can like take afterwards. So that's why we are then going to divide the k we obtained after this step with 3 factorial. Similarly, when 3 elements are remaining, for getting the third element, we have to keep the 2 elements aside, and to get the third element, we will divide the current k with 2 factorial. So similarly, we will be getting our permutation. So let's see now, when 53 here is divided by n minus I factorial, we are on position 1. So 5 minus 1 is 4 factorial. When we divide this number by 4 factorial, we will get quotient equal to 2, because 4 factorial is 24, 24 into 2 is 48, it's near 53, so the quotient will be 2, and remainder will be 53 minus 48, that will be 5. Cool. So now we have our quotient. So we will take the element present on the quotient index. So at index 2, there's 3 present. So we will be taking 3 from there and store it here. And also we will remove k from the 3 from there. Why? Because we don't want repetition of elements. And the nice thing here is the quotient here will always be equal to always be within 0 to the size of the array minus 1. For example, here the size of the array is 4, so the quotient will always be equal between 0 to n minus 1, that is 4 minus 1 is 3. Why? Well, when the size of the array was like 5, so 4 factorial into 5 was 120. So when we subtract 1 from it as previously said, so it would become 190. So 5 factorial is equal to 120. So we can get a number greater than that, like 120. And as we subtract 1 from it, we will get 119. So 119 is the greatest number we can get. Divide 119 by 4 factorial, the maximum number we can get is 4. So that's why we will always be getting the quotient between 0 to the size of the array minus 1. So we place 3 here. Now we move on to find the next element. So k will be now updated here to k modulo n minus I factorial. That will be the remainder here. So k will be now updated to 5. Cool. So now we have to divide this k by 3 factorial, because now we are left with 4 numbers and we have to get one number from them. So what number we will be getting for k equal to 5? So first we divide this k from n minus I factorial, where I is equal to 2. So 5 divided by 3 factorial, that is 6. So the quotient here will be equal to 0. So 5 divided by 6 is 0, quotient is 0, and r will remain 5, because 5 is less than 6, so remainder will be equal to 5. So we will get the element on 0 index now. So on 0 index 1 is present, so now we will be taking 1 from here and placing it here. Cool. Now we'll be moving to the third index. Now we have 3 elements left. We have to get one of the element, so divided it by n minus I factorial. That is, when we have 3 elements remaining, we can keep aside those 2 elements for later and divide this number, that is 3 here, like the k here, with the number of elements we have kept aside, that will be equal to n minus I, its factorial. So n minus I factorial will be 2 factorial, that is 2. So now we divide 5 by 2, quotient will be equal to 5 by 2 is 2, remainder is 1. Cool. So we have to get the element on q equal to 2, index 2. So we have 5 here. So we will get 5 from here, remove it from this array and place the 5 here. Cool. Now similarly, we have got remainder equal to 1, k will become 1, and now we divide by 1 factorial. So 1 factorial divided by 1 factorial, it's 1 factorial. So we will take the element present on the first position. So this q will be here equal to 1, and 1 divided by 1 is like the remainder will be 0. Yeah. So getting this permutation here, so we will take the element present on the first index and place it here. 4, and last element we will be placing here because we don't have a choice. So here we have got our required permutation. So it's that simple. So first of all, what you do is get n equal to 5. So you have these 5 digits and store it in an array. Then iterate through the array till we get all these elements. Like for this element, we divide it by n minus I. For position 1, we divided by 5 minus 1 factorial, that is 4 factorial. We get the digit present on the index of the quotient there. So we got 3, similarly we got 1, then 5, then 4, then 2. If our k was 52, then initially when this k became 1, the k would have been 0. So we would have gotten the element from the 0th index. So that's when we had like 2 and 4 there. So we would have gotten the 2 here. So our permutation would be 5 1 3 1 5 2 4. So even it even makes sense, because 52 is less than 53. So we would have gotten a permutation 4. So as 4 is greater than 2, we would have written 2 4 for 52 instead of 4 2 for 53. So finally we got this answer for k equal to 53. So similarly, now let's code this approach. First of all, vector v for storing the elements from 1 to n, then a string s to store our result. We subtract 1 from k because, as I said before, the indexing will be from 0 to n factorial minus 1 for easiness of the solution. Then we define a while loop. Now this while loop is doing the exact thing that we did here. That is, first we do n minus minus. So from n equal to 5, we are on n equal to 4, and then we calculate the factorial of 4. Now this fact n here is this fact here is just a function which will give us the factorial of n, and we store the factorial of n in this variable f. Then we get the element on index quotient. What will be the quotient? Well, it will be equal to k divided by 4 factorial. So our k was 53, so 53 divided by 4 factorial. So we will get the element present at v of index 2. So we got that element and we converted it to string, because in order to concatenate something to string, it should be either a character or a string itself. So we converted it into string and concatenated it to s, our final answer, and then we erased the element. As I said before, we also had to erase those elements which we have already been used to avoid the repetitions, because if anything with index 2 had come again, like for example for this 5 here we got index 2, so index to index 2, so it would have gotten 3 and 3 again, but we don't have the digit 3 two times, so that would have given us the wrong answer. So as we take the element from that array or set, we remove that element from the set or the array. So we remove the element on that index, so a new array is formed then, and then k is updated as k moduli f. As I said before, k became the remainder here. The remainder here is equal to k modulo n minus I factorial. So this is exactly that. F was n minus I factorial, and the previous k is updated as k modulo f. So that's it, and then we finally return the string s. That is the result we got from all these computations. So that's it for this question. Hope you got this approach and the solution. And finally, we have completed our 21 days of code. So congratulations again for coding continuously for 21 days. And now you can continue your own journey on LeetCode or start a new one on competitive programming like CodeChef, Codeforces, etc. So best of luck for your journey, and that's it.